Hi there, let's look at this problem from Interviewbit. In this problem, we have to find three integers from the given array in such a way that the sum is maximized on one condition that the three integers should be placed in strictly increasing order in that array. So for example, if we have 26, 25 and 24 given in this order only in the array, then they would not count as the maximum sum triplet because they are not in strictly increasing order. Now let's take a look at the solution approach. Since n is less than 10 raised to the power 5, we know that the complexity of this solution can be up to n log n. So let's us suppose that we are at this position in the array, which is highlighted in white part. We know that we need to find out the greatest element from the yellow part, which is lesser than the current element, and we need to find out the greatest element from the right or the green part, which is greater than the current element. So for the left part, we are going to take a balanced binary search tree, or in C++ STL we can also use an ordered set. And for the right part, we can take a maximum heap or a max heap, which can give us the greatest element. Both of these data structures support logarithmic insertions and deletions, and also we can find out the element in logarithmic time. So now let's take a look at what steps we need to follow. So first of all, we need to traverse the complete array and store all the values in the max heap along with the positions at which those elements are. Now after that, we need to traverse the array again, and we need to add the current element to the ordered set. And in each traversal, what we need to do is we need to find out the greatest element from the ordered set, which is lesser than the current element. Also, we need to find out the greatest element from the heap, which is greater than the current position. Now let's take a look at the code. So first of all, we need to take a maximum heap. So we'll take a priority queue. And this priority queue will contain points. Let us define a point class. This will contain two public variables, members. First one will be value and the second one will be position. And let us make a custom comparator. This takes 2 points by reference, so point P1 and point P2, and returns P1.val is lesser than P2.val. Now let us pass this comparator as well. Now this makes it a max heap. Now let's traverse through the array. Let us create a point p dot val is equal to a of I, and p dot pos is equal to I. Let us insert this in priority queue. Now for the next step we need to take an ordered set. So set int s, let us push the first element. Now let's traverse the array from I equal to 1 to I is less than a dot size minus 1. We are traversing it from I equal to 1 to a dot size minus 1 because for the leftmost element we do not have an element towards its left, and for the rightmost element we do not have an element towards its right. So in this we need to push each element, current element, and we need to find out the leftmost greater element from this set. So let's name it left and initialize it to 0. Let's take an iterator which will find this the position of this element that we just pushed. So now if idr is not equal to s dot begin, left is equal to value at itr minus itr. So decrease the iterator because we need to find out the element which is lesser than the current element. Now let's try to find out the right part from our priority queue. So before we do that, we need to pop out all the elements which have an index lesser than the current index, that is I. So while pq.top dot pos is lesser than or equal to I, pq.pop. Now all the elements which were before the current element have been popped. So now we can find out the greater element from the right part. So right will be pq.top dot val. Let us take a maxsum variable and initialize it to 0. Now we will update this maxsum on one condition, that is if left is lesser than current and right is greater than current element. Sorry, this will be int, and int current will be a of I. Also left should be greater than 0. and we can also say that right should be also greater than 0, or we are fine without that as well. So we update maxsum left plus right plus current. Finally we return the maxsum. Let's try to submit this. Okay, sorry, it needs to be an insert instead of push, so s.insert. So the solution has been accepted. Thanks for watching.